There we go. All right, we're recording. So we're going to talk about 6.4, which is mid-segments, and then when I let you guys go, we're going to take the quiz and also do a very short assignment on mid-segments. Okay, so go ahead and grab your notes, and we're going to jump right in. Oops, didn't want it in that window. Come on. Here we go. All righty. So first of all, 6.4 mid-segments. We need to know what a mid-segment is. Because we are going to talk about the mid-segment theorem, but first we need to know what is a mid-segment. So here we go. A mid-segment of a triangle joins the midpoints of two of its sides. So it's a segment between the midpoints of two sides of a triangle. All right. A segment between the midpoints of two sides of a triangle. So what this looks like is if I've got a triangle going here, and we'll say that these are the midpoints of each of the sides. So this is the same as this, cuts it in half. These are congruent, and these are congruent. A mid-segment would be a line between any two of these points. So that would be a mid-segment. This would be a mid-segment, and this would be a mid-segment. So all three of these would be mid-segments. Okay. So the thing with mid-segments that we care the most about is usually something called the mid-segment theorem. We're not as concerned with, in order for them to be a mid-segment, it has to cut the side in half. But other than that, what we're most concerned about is the mid-segment theorem. So that's what we're going for next. Okay. So the mid-segment theorem says if a segment joins the midpoints of two sides of a triangle, then two things happen. So basically, if we have a mid-segment, then the segment is parallel to the third side. And two, it is half as long as the third side. Okay, so if we have a mid-segment, then that segment is parallel to the third side and half as long as the third side. I'll let everyone write that down. And then we're gonna take a look at what it would be, or what that's telling us with a picture. And then we're gonna talk about some examples here. Okay, so in a picture, we're saying if we have a triangle and there's this mid-segment, then what happens is that we have parallel sides, so these are parallel to each other. And remember, when we denote things as being parallel, we have an arrow in the side. So they're parallel, and then if this is some length x, then this is twice as long, it's 2x. So if this is some length x, then this is 2x. If this is 5 units long, then this is 10 units long. If this is 1,000 units long, this is 2,000 units long. So that's the main idea behind our mid-segment theorem. This part, the length piece, is what we're going to use the most often, and that's what we're going to focus on mainly for today. Tomorrow we'll talk a little bit about the parallel piece, but for today we're mostly talking that length portion of things. Okay. So we're going to do a couple of examples that involve the mid-segment theorem. So we're going to start with the simple one, and then we'll talk about the algebra version of things. So the first example, got our triangle here. We know this is a mid-segment because these two are the same and these two are the same as each other. They're congruent, connecting midpoints. So then if this side is 48 units long, we want to know what is Wx. All right. So what do we think? What's Wx going to be if we know that Tu is 48 based on that mid-segment theorem? 24. Awesome. Yeah, because we know that it's going to be half of 48. 48 divided by 2 is 24. So Wx is 24. So that's the simple version. We can kind of go back and forth between this one being half the size of this one, or this one being twice the size of this one. The other version of a problem that you might see is going to involve a little bit more in the way of algebra. Okay. So this one, we've still got our mid-segment. Let's see, J, K, L, M, N. And we are going to be told that Mn is x, and Lk is 3x minus 2. We want to find the value of x. Okay. So what we need to do here, first, what I would personally do is take the information that I'm given and label it in the picture. So Mn is x, so I'm going to put an x there. Lk is 3x minus 2. So that's what I'm putting down here. Okay. But I can't just set them equal. We're used to kind of setting things equal in this chapter so far, right? Most of the things we've done is setting things equal. That's not what we're doing here, though. Let's see. Yeah, you could do it that way, Caleb. You could go 3x minus 2 divided by 2. Or possibly the easier way on this one would be to multiply this one by 2 first. But either way of setting it up is fine. You're just going to end up multiplying by 2 on both sides anyway if you set it up that way. So whichever way you would like to think of it is fine. But what I would do here is multiply this one by 2. So you get 2x equals 3x minus 2. Because 2 of this one here, mn, is going to be equal to lk. So 2 of mn equals lk. So 2x equals 3x minus 2. So then I would go minus 3x. So we'd get negative x equals negative 2. So then divide by negative 1 on both sides to get x equals positive 2. All right. So that's kind of the algebraic version of these kind of problems. Let's do one more like this, because there are instances where you'll want to remember to do things like distribute. So we want to make sure we go over that. Okay. So next problem. There's our picture. This time we are told that nm is 3x minus 10 and jl is 5x minus 2. And we want to solve for x. Occasionally you'll be asked to find the side length as well, so we'll also say, and find JL, that length. Okay, so for this one, we're going to take a similar approach. I would go ahead and label things first. 3x minus 10 is the shorter side here. And then 5x minus 2 is the longer side. So this is the one that I'm going to multiply by 2. But when I do it, I need to make sure that I multiply the entire thing. So we want to make sure that we distribute. And the way that I ensure that is I put some parentheses around the 3x minus 10. And I make sure that the 2 is on the outside of the parentheses. And then it's equal to 5x minus 2. So remember, small 1 times 2 equals big 1. So then we do the distributive property here, and we go 2 times 3x is 6x. 2 times negative 10 is minus 20. Always make sure you distribute to both. I see a lot of the most common mistake with this kind of problem is when people distribute to the first one, but not to the second term there. So make sure we get them both. Then I would probably subtract 5x from both sides. We get 6x minus 5x is x. And then we would add 20 to both sides. But we can't see that. There we go. Moving it on up. So we get x equals 18. So there's part of our answer. We solved for x. And now we got to find JL. So we know JL is 5x minus 2. So that would be 5 times 18 minus 2, which is 90 minus 2, which is 88. So the other part of our answer there is that JL equals 88. Okay. So that's the mid-segment type of problem. A lot of the ones that you're going to see are going to look like that first example where you just have to multiply by 2 or divide by 2, depending on if you're given the big side or the small side. And then there's some of them that are going to look like example 2 or example 3, where you have to multiply one of the sides by 2 and then set it equal to the other side and solve for x. Any numbers that we're not sure where they came from, any steps we're not sure how they happened in any of these examples. Anything we want to go back to? Okay. If not, then we're going to jump over and take a look at what our assignment's going to look like for today.